So I did say that we were going to use matrices to work us towards solving for 2 unknowns and 3 unknowns, etc. So as a step towards that, let's just have a look at this example here. If I multiply this matrix by this one, I get this. Try it out, you'll see it's true. It's obviously true. Therefore, that means, therefore, if I've got this, x plus 5y, 8x minus 3y, that's going to be the same, identical as this. 1, 5, 8 minus 3 times that. Okay. So you can probably see where this is going. So this would be, depending on what x and y was, this would, if this were simultaneous equation type situation, this would equal some value. Let's call it a and b. So this would equal a and b. So we'd know what a and b was. We were trying to find out what x and y is. So you can see that's going to be a step that we'll come to later when we're solving for 2 and 3 unknowns. So heading towards our target of using matrices to solve for unknowns, we're going to be starting with obviously 2x2, 2 unknowns, because that's the easiest. It's not just easier because of the quantity, it only being 2 rather than 3, but it's actually the process is easier as well, as we'll see in a while when we come to the three unknowns. It's not easier or harder in software, that's an important point, but doing it manually on paper, doing it by hand, it's a lot harder to find 3 unknowns than it is to find 2 unknowns on paper, but just as easy in software, which is one of the benefits of matrices. You can use it in software to solve difficult problems. Anyway, so a determinant is like we could say a subset of the matrix function. It's one of the things that apply to it, a function that's applied to it, and it's quite easy with 2 unknowns, with a 2x2. When you do determinants, it's got to be a square matrix. That's the first thing. This is a 2x2, okay, which obviously is going to apply when we're finding our 2 unknowns. It's going to be this kind of matrix, as we'll see. So this is one of the steps closer there. So we're going to find the determinant of these numbers. So the determinant is easy. A equals this, so this is a matrix with a capital A equals this. The determinant is written as 2 solid lines, 2 vertical lines, as also is the solution. So 2, that's supposed to be a straight line. So 2, 3, 4, 5. And solution is not that difficult when you get the hang of it. And all you do is you go down the negative slope 2 times 5. So the answer to that would be 2 times 5. And then you subtract from that, going back up 4 times 3. Okay? So that's going to be, that's obviously 10 minus 12. So minus 2. Okay? Should be a 2, looks a bit weird. 3 fourths is 12, yeah. 2, minus 2. Okay? So that's all there is to it. Let's do a couple more examples, just to really cement that in there. If I look at some other numbers, let's say, for example, the determinant of b, where b is, so b, the determinant of b is, let's say, minus 2. So we've got some negative numbers in there to make it that little bit harder. 3, minus 4, and 5. Okay. So again, going down, so it's minus 2, this is why it's a good idea to start using brackets, times 5. brackets as I mentioned. Going back up, so it's minus, open bracket, minus 4 times 3. So that's going to give me, I'll do it underneath because it's easier, minus 10, and then minus a minus, so 12. So it's going to be plus 12. So that's going to be, so minus 10 plus 12 equals 2. Okay. Let's do another one. Might even do a couple. I'm just going to make some numbers up. So if you've got this nailed down, you can leave the video at this stage because this is all I'm going to do for the rest of it. Let's say 1 minus 2, 3 minus 1. So that way 1 minus 1, 1 times minus 1 minus going back up. So 3 times minus 2 gives me, so 1 times minus 1 is minus 1, minus a minus 6 will give me, so plus 6, so it's going to be 5. Okay? Let's do a couple more, and then I think you'll see pretty much got it nailed. Incidentally, if you've left the video already, you won't hear this, but if you do a 3 determinant of 3b3, it's a lot harder. And I've never actually tried to do it by hand with the 4 before, because I suspect it's really horrendous. But let's do a couple more just to finish. Minus 2, 2, 2, minus 2, why not? So we've got minus 2 times minus 2, minus 2 times 2. Okay, so minus 2 times minus 2 is plus 4, minus 4 equals 0. That's a special case, that, which we won't be going into now. Okay, and then another one just to complete the day. So minus 1, 3, 2, 3. So minus 1 times 3, minus 2 times 3. Okay, so that's going to be minus 3, minus 6. Double check myself, yep, minus 9. Okay, let's do another one very quickly, just to show how easy it is. 2 minus 1, 3, 2. 2 times 2 minus 3 times minus 1. I can't work too low down, I start to get difficult to write. So that's going to give me 4 minus a minus 3. So it's going to be 7. It's going to be plus 7, plus 3, 7. Okay? So hopefully you've got that nailed down. Just practice if you're not sure, do a few. Very easy to do. A lot of software, a lot of calculators will actually do them for you so you can check your answers. The next part of our toolbox towards solving simultaneous equations to find two unknowns, x and y, is this process here. So we're going to use, one of the rules of matrices is the inverse of, looking at the inverse of a 2by2 matrix, is that if you multiply the matrix A by its inverse, you get this identity matrix. Remember that? This is an identity matrix where you've got diagonals of 1s and all the other numbers are zeros. It doesn't have to be a 2by2, it can be 3by3, 4by4, you get the same principle. And what this rule says, that if you multiply that A by its inverse, you get I. And also, funny enough, if you multiply them the other way around, remember we said you don't get the same result when you're doing matrices. You do in this particular case, multiply it by its inverse the other way around, so A inverse times A still gives you I, where I is the identity matrix. So take this for example. This is the matrix, this is its inverse, and it gives us that result. So you might want to try that, see what you think. But the other thing is, if I do it the other way around, so that would be 2 minus 1 minus 7, 4, 4, 1, 7 and 2. That also gives me 1, 1, 0, 0. Again, try it out to practice your matrix. It doesn't look like it's going to happen, and it does. If you do it right anyway, it comes out just as this result. Just when you're feeling it won't, it does. So have a go, see what you think. So that's something just to keep locked in there, this rule. Next part, obvious question, is how do you find the inverse of a matrix? So how is this related to this? It's if you think about it, you might spot there's a little bit of a pattern there, that these two numbers have swapped round and these two numbers have swapped the signs. There's a little bit more than that, slightly. There's a determinant comes into play. Let's have a look at an example. Let's use these numbers. Let's have a look at this. Right, the formula for finding the inverse is this. I'll put it over here. So the inverse of A is equal to 1 over the determinant of A, so that's A, the determinant of that times, so in fact let me write this out another way. Let me write out a better formula. Yeah, let me just redo that, start again there. Make a bit more space for myself. Small board this. Okay, so in red, let's say if A equals A, B, C, D, so 4 numbers, then the inverse of it, so minus 1 for the inverse, quite often used text, will be this. 1 over the determinant of A that we've done times, so it would become D and A, so those two numbers swap places, and these two numbers swap signs. So if they were plus, they become negative. If they're negative, they become positive. So that's as simple as it is. So this is one of them functions that does get easier the more you do it. So let's have a look at this one. So what would be the determinant of that? So it's 1 over A, 1 over the determinant of A times, so swap these two numbers around, so we've got 2 and 4. So 2 swap places with 4 and 4 swap places with 2. And these two numbers swap the signs. So they were both positive, so they're both negative. So that's it. Only thing is, what's the determinant of this? So let's have a look. So the determinant of A is 4 times 2 minus 7 times 1. Whoops. That's a terrible one. Which is 8 minus 7, which equals 1. Okay. Now, in that previous example when we were doing determinants, there's one example where we got a 0. And obviously if I get a 0 there, it fails, it doesn't work. And that's a particular circumstance that I'm not going to go into with you at this point, or maybe any point. But So this one was 1 over 1. So basically, remember when we looked at scalars, multiply it in by the scalars, and you just get the same. In this case, because it's 1, you just have 1 over 1 is 1 times 1, so everything would stay the same, which is why in that last example, it was chosen that way to make it easier. Okay? So that's the inverse. So let's have a look let's do some examples. So let's do some off my sheet. So for the example, A equals 4, 5, 2 and 2. So the inverse of that is going to be 1 over the determinant of A times, so swap these two around, 2, 4, and then these you swap the signs around. Right, what's the determinant of A? So the determinant of A is 4 times 2 minus 2 times 5. Okay, which gives me 8 minus 10, or minus 2. Okay? So my determinant of A is 1 over minus 2 times 2 minus 5 minus 2, 4, which if I multiply in my scalar, I'm going to get, let's double check that right, yeah. So this would be 2 divided by minus 2, so it's going to be minus 1. 2 divided by minus 2 is going to be plus 1. Minus 5 divided by minus 2 is going to be 5 halves. 2.5 if you wish. And they're positive and this one's going to be minus. So 4 divided by 2 is minus 2. Okay? When we use this for finding the two unknowns principle, we won't bother multiplying this out. We'll save this part until the last step. Probably say more than I should because it might add to the confusion, but you'll see that when we get to that stage. Okay, so I'll do another example very quickly. Yes, I can hear your cry. Please do, please do. Right, okay then. Let's have a look at, so A equals minus 1, 3, minus 2, 2. I'm going to find the determinant first. Determinant of that is minus 1 times 2 minus 2 times 3. Okay, so down that way, minus going back up. That's going to give me, so that's minus 2, and that'll become plus 6. So it'll become 4. Okay, just double check that. That's minus 2 plus 6, yeah. Okay, so plus 4. Okay, so therefore, our inverse of A is 1 over 4 times, swap the two numbers around. So 2, the signs go with it when you swap them around. Okay, they stick with it. The only place the signs are going to change is these, so they swap the signs. That'll be now minus 3. These stay in the same place, but we swap the signs. So that's still a 2, but it's now become plus 2 because it was negative 2. That was a plus 3, so it's become minus 3. And they are completely swapped around, taking the signs with them. Okay, so if I multiply in my scalar, my quarter, I'll get 1/2 You can see why sometimes you just don't want to bother multiplying it in. So this is also half. You could go decimal, of course, and then 3/4 is getting messy, and minus 1/4. Okay, so you probably want to leave it like this. So the next part of the puzzle is this, or the next part of the solution is probably better, is this. We're heading to this formula here. This is the formula that will allow us to be able to solve for 2 unknowns. It's also the same formula that will allow us to solve for 3 unknowns and so on. So, but firstly, there's one thing I need to cover first, that A times the identity matrix leaves it the same. So if you multiply anything by the identity matrix, it stays the same. Okay, we saw earlier that A times its inverse gave you I, and that was the previous thing. But we're now going to see that A times the trig identity just leaves you with A. Okay, so let's have a look at it as an example. So this is my matrix. This is my identity matrix. If I multiply them out, try it for yourself, I get these numbers, which then leaves me with, so 2 times 1, 2 times 0, it's gone, so that's gone, that's gone, that's gone, that's gone. So I've just got 2, I've got 1, I've got minus 1, and I've got 2, which should be the same as that, and it isn't because I've made a mistake. That there should be 2, and it is 2 there, to be fair. 2. Okay, so remember that anything times the identity matrix leaves you with staying the same. Okay, the same the other way around as well. As we saw earlier. Right, so keep that in mind. So let's make a statement that, let's suppose that A is a 2x2 matrix and AX equals B. So AX equals B. X and B are 2b1s. So A is a 2b2 and X and B are 2b1s. So what we're saying is A, B, C, D times E, F equals GH. Okay? So there's nothing wrong with that. That makes sense. If I multiply these numbers by these numbers or values, I get this answer. Okay? So that's fair enough. Breaking no maths rules there. Let's say I pre-multiply both sides. By the way, I didn't mention this earlier, in matrices you do need to define whether you're doing a pre-multiply or the post-multiply, because remember there was a difference. A times B was not B times A. So if I pre-multiply both sides by I, the identity matrix, okay, then we get, read me notes, it'd be a good idea. So I have done that wrong. Need a bit of editing here. Let's pre-multiply. Okay, so I've done that and I've not broken any rules. So let's now multiply both of them by the inverse of A. Pre-multiply, because you've got to define it's pre-multiply, particularly for this one. Okay, so I pre-multiply both sides by the inverse of A, which again doesn't break any rules because you've done the same to the left-hand side as the right-hand side of our formula. Now, as we know that this is inverse times A gives me I. So I've now got I of X, the identity matrix, which we looked at earlier. So we've got this now. Okay. But if I multiply anything, I leaves it unaltered. So this, I've now got this. Okay. So this is the formula we're going to use. And at this stage, we're at the realm of doing examples. So now we've got all the building blocks to solve for two unknowns. So let's take an example. Let's say that 5x plus 2y equals 1 and 8x plus 3y equals 4. Now we saw earlier that we could split this up like this. This part can be split up like this. So 5, 2, 8 and 3. If I multiply it by, that's right, yeah, sorry, x and y, okay, multiply that into that as a matrix style, I'd get back to this part, and we know that this equals 1 over 4. Okay, so I can define this as A, so this is A, this is my x, and this is my B. Okay, now we've got this formula here that says this, we're looking for x, so this formula, we can use this formula to find out what x is. So we could write it the other way around, say the inverse of A times B gives me x. Give me an x matrix, this one, with the numbers in. So we found x and we found y. Okay, so let's have a look at that. So let's find the inverse of A first. Let's, yeah, I'll do it in the same colour. So A, do it over here. Is going to be, so we swap the two numbers round. It's 1 over determinant of A over, so swap the numbers round, 3 there, 5 there, and swap the signs round. So they become minus and negative and negative. Okay. Now the determinant of A is 3 times 5, so I do it from this one, 5 times 3 minus 8 times 2. So 2 times 8, 8 times 2, it's the same. 8 times 2. Okay, which gives me 15 minus 16, so minus 1. Okay, so the determinant of A is minus 1. So my A inverse is 1 over minus 1, so it's just minus 1, times 3 minus 2 minus 8, 5. Okay, so far? So that's that bit. Now B is this. So if I multiply that by B, that'll leave me with x. Let's try it. So in other words, we could, that formula, A times the inverse of A, which is 1 over minus 1, let's just make that minus 1. Just going to change all the signs, obviously. Obviously I could do this straight off. I recommend, because it's not always a nice easy number like a 1, it can be fractions as well, and often is fractions. Let's just leave it as it is like that, and then we'll do it the last stage when we've multiplied. Let me write it in and I'll explain myself better. So this is A, the inverse of A, times B, which is this one, 1 over 4, equals x. Okay? this. That times that's going to give us a 2b1 matrix. Now just going back to this, yeah, I can multiply that into this case quite easily and multiply that into that, and it's quite nice and easy. Sometimes though, if this was a fraction, say a quarter or minus a quarter or minus an eighth or 22 or some number not as friendly as this, and I multiply that into that at this stage and then multiply into that, it makes the maths quite hard when you do it on paper anyway. So I'm going to leave that and just what you normally do is just ignore that, multiply that into that, and then multiply that in as your last step. So I'm going to multiply this by this matrix, in other words, and then do that last bit last. Okay, and that works fine. Try it both ways if you're not sure. Right, let's see what we've got. So 3 times 1. So 3 times 1 minus 2 plus minus 2 times 4. Okay. All over minus 8 times 1 plus 5 times 4. Which gives me, let's have a look. I'm going to do all the steps because I easily go wrong, as you know. 3 minus 8. Minus 2 times 4 is minus 8. And then minus 8 plus 20. Okay. Which is x. There's a minus 1 in front of that, don't forget. To multiply in, let's put that minus 1. Minus 1 times that would equal x. So if I do this, let's not put that in yet because I don't want to cause any more confusion. Minus 1 times, so 3 minus 8 is minus 5, and minus 8 plus 20 is 12. Multiply in the minus sign, makes that plus 5 minus 12. Sneaky look at my notes here, just make sure I haven't gone wrong. Looking good. So what that's saying is, running out of board, that x equals 5. Okay, that's that bit of our matrix there. Sorry, that bit of our matrix there. X is 5. Y is 12, minus 12. Now, what's the test? How do I know I've got the right answer? Very simple. Put these numbers back into here and see if we get the same answer. So let's say, for example, this is 5. Because I'm running out of board, I'll do it up here. 5 times 5 plus 2 times minus 12. So that's 5 5 is 25 minus 24 equals 1. So that one's correct. So it's usually, 1's usually enough to make you feel good about yourself, but let's have a look. 8 times 5 is 40. 40, and then that's minus 36. Okay, which is 4. Yeah. Oh yeah. Okay, cool. So we'll do a couple more examples in another video, and then because I quite understand if at this stage you're a bit lost what's just happened, but if you go through the video again it starts to make sense. But I'll do a couple more examples in another video, separate video, so it's just not overwhelming in one go, and you'll see it starts to come together quite well. Okay.